Hello, and welcome to Appendix H. This section is actually a bonus section which is not in our book. Um, this is a topic, it's sort of a collection of topics: the Pythagorean theorem, the distance formula, the midpoint formula, and equations of circles. So it's a few different topics that are not actually in our textbook, but it is part of the course outline for our class. And I think it should be in our textbook. I think this is an important part of algebra, of any algebra class, but for some reason our textbook doesn't include it. So I put together this section sort of on my own. So first of all, uh, we're going to go through these notes here. If you don't have these printed out, they are available in the shared Dropbox folder. Uh, and we're going to do the distance formula, a few other topics, like I said, and and circles. We're going to see a bunch of these things that are all sort of the same thing. And then at the end of this PDF, you'll see the homework here, because this homework isn't on Wiley Plus. It's not in the textbook. So the problems are all going to be here. And the due date here is not right. You are going to write it out on a piece of paper. This semester, this spring 2020 semester, well, we're uh, doing everything online. What you're going to do is do it on a piece of paper and then just take a photograph of the pieces of paper and email it to me for me to grade. Uh, and I'll post the due date on Canvas later. So let me just fix that. All right, so let's start by looking at the first bit of this, the Pythagorean theorem on the first page here. First of all, I'm going to go over the theorem, and I'm going to do one of these exercises, but you should definitely do the other part of this exercise, and also exercise 2 on your own. Some of these activities that we do, they're called activities because I sort of stole them from a different textbook written by my friend Catherine Yoshiwara and Bruce Yoshiwara. So these ones are going to be pretty tricky. You might have trouble doing them on your own, so you might need to sort of follow along with a video. But as always, the more you do on your own, the better off you'll be, and it's good to use the video to get unstuck. So what the Pythagorean theorem says, jumping into this, is that if A and B are the legs of a right triangle, that means the sides next to the right angle here, then the hypotenuse, C, the opposite side over here, is going to be, if you square C, you'll get the same thing as A squared plus B squared, is what the Pythagorean theorem says. So, and this is true with any right triangle. It has to have a 90-degree angle over here. With other shapes of triangles, it's not true. So let's use this to find the missing side here. So what we're given are the legs 2 and 5. If the missing side here is C, then we can plug in the 2 for the A and the 5 for the B, because these are the sides adjacent to the right angle, to that 90-degree angle. So I'm going to plug them in to the formula here. That should be equal to the hypotenuse squared, the side opposite the right angle. So, yeah, 2 squared plus 5 squared is equal to c squared. 2 squared is 4, 5 squared is 25. So this comes out to be 29 equals c squared. And normally I would say you have to, when you take square roots of both sides, you need to include the plus or minus here on one side or the other. But in this case, it doesn't make sense to say that the length of the side of a triangle is a negative number, so we're not going to count that. This is really just the square root of 29. So we're going to say C is just the square root of 29, which you can approximate with a calculator. I mean, just looking at the picture, it looks like it's a bit more than 5, maybe 6 inches or something. So I'm going to open my calculator here. and we get that it's 5.38 inches. Not quite 5.5. So that's an approximation, but it's pretty close. Okay, so that's that triangle. Let's now here's where you should pause it to do B, get a little bit of practice with this, and then go on and do exercise 2 yourself. These are very similar to what I just did, and it's very, very important practice to get. So let's pause it here. Okay, now that we're back, here are the answers for part 1, part B here. So we're doing 1 squared plus 1 squared, that's one leg squared plus the other leg squared. That should equal c squared. 1 times 1 is just 1, so is the other 1 squared, so that just gives you 1 plus 1 is 2. So that means c is the square root of 2 kilometers. And that turns out to be about 1.41. Approximately 1.41. That kind of makes sense. You can tell it's longer than 1 because, like, this distance here is 1. And this going diagonally is going to be longer than that. You can also tell it's shorter than 2 because if you went this way and then up this way, that would be 2 kilometers. But going diagonally is going to be a little shorter than that. So it turns out it's about 1.41 kilometers. All right, so exercise 2, hopefully you did that as well. So let's look at A first. If you want to get the length of this side, you could just count. It looks like 3 units. You could also get that by the same way we calculate like the delta y when we're talking about slope and the delta x, by saying if this y coordinate is 7 and this y coordinate is 4, then the vertical distance here must be 7 minus 4, which is 3. And same thing with this distance here. This change in x, this horizontal distance, you could just count it and see that it's 4, or you could do the ending x coordinate here, which is 0 minus -4 to see how far apart they are there. So that would be 0 minus -4 is 4. So those are the legs of that. Now the hypotenuse here, this side, we're going to use the Pythagorean theorem to say that this is 3 squared plus 4 squared must equal that hypotenuse c squared. So 3 squared is 9, 4 squared is 16, so 9 plus 16 adds up to 25 equals c squared. So the square root of that is 5. Okay, so this one is 5. So that's that one. With B, I want to emphasize the same method of subtracting x coordinates to get a horizontal distance or subtracting y coordinates to get a vertical distance, because that's going to be really important for understanding the formulas in a minute. So this horizontal distance here, you can see it's just 1, but you could also get that by doing 4 minus 3 is 1. And then the vertical distance here, you can see is, if you can just count it to see it's 5, you could also get that by doing 6 minus 1 is 5. And then when you use the Pythagorean theorem, we're going to do 1 squared plus 5 squared. Those are the two legs to get the hypotenuse, the other side, which is going to be just a little bit longer than 5, it looks like. Should be equal to c squared. So 1 squared is 1, 5 squared is 25. If you just do the square root of both sides of that, you're going to get the square root of 26. And again, I'm ignoring the the plus or minus because you can never have a negative distance on the other side. So we're just talking about the square root of 26 is c, which is just a little bit more than 5. 5.1 about. Okay, so then let's look at this one. For C, this vertical distance here, you can just count it and get that it's 3, or you could do -1 minus -4 to see how far apart that is. And that is -1 plus 4 is the same thing as 3. So that's a distance of 3. And then same thing here. I'm going to subtract these x coordinates here and here. 5 minus -3, which is the same thing as 5 plus 3, is 8. Tells you that these are 8 apart. So in this case, we're going to do, so those are the two legs that have a right angle here. The hypotenuse over here, the c, we can get by saying that 3 squared plus 8 squared is c squared. And so that's going to give you 9 plus 64 is c squared. 9 plus 64 is 73. And we're going to do the square root of both sides to cancel out the c squared. And so we're going to get the square root of 73 is c, and that's approximately 8.54. All right, so that's that. Next, we're going to look at these activities. I definitely recommend trying the activities, but they are tricky and you might need a little help. So I'll go over those in the next video.